11. You have to provide 7 things. To constructor, default and custom, destructor, copy constructor, move constructor, copy assignment, move assignment. The rule of 7 in general. Right, so this is what we had to talk about for constructors. And to have more fun, it's good to know that when you design numerical types, maybe for some other types as well, you can overload operators. Operators are a lot of them. There are something like 25 operators in C++. Interesting is you can't introduce new operators if you want. To have an operator which does whatever fancy thing, you are not allowed. You have to stick with what is provided by the language, but you can design them for your types. And for our, some operators are assignment, plus, minus, multiplication, arithmetical one, plus, plus, minus, minus. And then we will see index operator, we will talk about it. Input and output operator, we will talk about them. But we won't talk about, and okay, so simple operators, less, equal. Relational operators are also very simple to implement. But we won't go and talk about new operator, how to implement this. This is too advanced for our thing. We won't talk about member operator, member of a class or of a structure operator. We don't. Again, it's advanced. Or function operator. It's another operator which defines a thing as a function. So there are operators we don't touch, and you are not required to know them. But what we cover and examples you have here, it should be handleable by you. You can handle them. So as you can see, it's good again to go and see what problems are associated. And for the last topic, which is constant methods, we have touched on this, but we will see again why we have to use this. And for your assignment, probably you have seen that many of your methods are constant at the end. Operators are expressions which, for users' point of view, are very familiar. Plus, everyone understands what plus is about, or division, or assignment. But all these operators are, in fact, functions behind the scenes. They are there for, it's called sometimes syntactic sugar, to make our lives easier, our life easier, in general, of the user, of those types easier. One thing, and sometimes you will see expressions are much simpler if you use operators, because you rely on priority rules or other things. So, one part for which object-oriented programming is considered a good methodology is that you can very easily extend those operations for your types, which sometimes is not so easy in C. You can do everything you do in C++, you can do it in C, everything, but with much more work. Right. Assume that you don't have plus operator or multiplication. Expression will be a little bit cluttered like this. For example, to add two complex values or other values, you have a function, you have to know the name of the function and how many parameters you pass it. when you talk about multiplication, something which is written a plus b brackets times b plus c brackets becomes something like this. Add a and b first, add b and c, and then multiply. So this it's a little bit much more than a plus b times b plus c. Right? We still need brackets, but this is much more clutter. What is interesting, Java does not provide operator overloading. So in Java, when you want to do something like overloading, multiplication, and addition for your types, you have to provide functions. And the expressions can become like this. So Java does not allow operator overloading with the new types. As I said before, probably you know already that behind expressions like this we have functions. So, first operator is assignment. And we will go from first approach to implement the assignment, and then we will see what are the problems and how to fix them. So to be aware, the first approach is not necessarily the final solution. In case the class does not have pointer data members, the system provided assignment operator is good enough. It copies integer to integer. If you have 3 data members, integer, float, and char, integer to integer, perfect copying, float to float, char to char, no problem. But when you have pointer data members, then again it works with shallow copy and we have problems. Therefore, you have to implement the assignment operator. You have to know when the assignment is called as compared when the constructor is called. Here, we introduce a new object into the space, into our program. This is a declaration of the variable a. So there is a constructor provided by the class taking 2 arguments. Here, we introduce b into this. It's a declaration of the variable b, but this is constructed from a, and this is copy constructor, or move constructor, or copy constructor, sorry, because this is right, a left value. So copy constructor is called. Now, here, the default constructor is called. So you are aware that at this moment, A is defined, C is defined, got some data. And what we have here is we change the value of a predefined object C to be set up with the values in A. A stays unchanged, C gets new value, right? So in this case, we have assignment operator called, because the objects were already defined before. We will use, just to demonstrate the construction of assignment operator with this unusual complex class, where we have 2 data members, but they are defined as 2 floats through a pointer, because this is when you have to deal with this move constructor, destructor, and assignment operator. So what we have here is, in fact, data which has m values 0 as its first element and m value 1 as the second element. In other words, something like this. We have m floats pointer, which has that m float, what is called m values, sorry, m values has just two. This is m values 0 and m values 1. So if we assume that we assign the value 3 and 9 here, we, in our mind, say that we represent the number 3 and I. This is a complex number from mathematics. But what we do, we work with pair of values. The C++ standard library has a complex type, which has two data members, each one float values, not pointers. So this code shouldn't be used for real application. If you need complex data, use the complex class, it's complex type for scientific things. But for our example, we want to see how to design the assignment and other tools. Be aware, m values will have just two elements associated to that pointer. That's why the constructors are designed as you will see. Now, our custom constructor, which takes two arguments to set the real part and the imaginary part, are there. And as you can see, this is a default constructor and custom constructor. We will see what happens when we look at the implementation, that we have some memory allocated for two spaces, whatever. Then we will have copy constructor, define move constructor, destructor here, and we will look in particular how to perform assignment. Be aware, assignment for these types, working types which have values also of pointer type. Notice that the custom user-defined constructor allocates two memory location. Yeah, we need just two cells for our m values, and then we set the values here. Then this is the copy constructor. Simple. Constant reference, it tells you this is it. And what we have here, there is no size to deal with. We just have to have this current object value set from the argument which is passed. The move constructor, as you can see, we work with pointers, and because this from here shouldn't be, the memory which was there shouldn't be used by this object, we reset it to null. And then the destructor. We have used new, we have to use delete in the destructor. So, as I said, pairs, and then set to null pointer for good housekeeping. And now let's look at the assignment operator. So, our assignment operator should perform, yeah, if this is one object X, I want to have the object Y, which was coming with its values. Remember, it was something which was previously defined with a default constructor or whatever, and it has some value here, -1 and 3, maybe. What we want is now to assign, let's say, to X the value Y. We want to perform this. So, there are some issues we have to deal with. First of all, Y should stay unchanged and in good health after assignment. And what we want for M value is to end up with -1 here and 3 here. -1 here and 3 here. Sometimes, in this case, we have the same size here. But sometimes be aware that this object X might have elements where it points to, if you think of a string. And y might have 10 elements. 10 elements. So this has 3, and this might have 10 elements here as a size. Once again, think of a string object with an array of characters. How can we fit into 3 cells, 10 cells? That would be a problem. So we have to have in mind that our assignment operator has to work not only for complex type, but for any possible type. The assignment operator, we are talking at the general pattern. At the general pattern for an assignment operator. Right. Maybe we can move from complex. What if instead of complex, we say array of chars, array of integers, and I want to design assignment between an array of objects and another array of objects. They can have different sizes, so always we have to remember this. So, one first approach would be this one. Notice, this is the name of the function, operator assign. This is the name of the function, and this will always have operators associated to the symbols will be constructed like this. Operator, and what is the symbol? Operator plus, operator whatever. This is the argument, which means I, okay? And this argument has to be passed by constant reference because this hasn't to change, has to stay in good shape as it was. Efficiency, reference, passed by a constant, not change it. That's the story. And how we do this? Right. What we want is give me enough memory for what I have to do. In this case, we stick with 2, but have in mind that situation when we might have more than 2 floats. We have an array of floats, and we want to assign between an array of floats and another array of floats. We have to make sure that where we assign, we have enough space. That's why we use the size and allocate memory to be able to copy 10 elements in something which previously accommodated just 3. So this is one thing. And then we copy value by value. This, it's okay. And because we return by reference, we return the value to which this point, so memory where this current element is located, you will see. This is standard for assignment operator. Always return, dereference this. You can't avoid it. So if we go here, what we have for our example, we have this gets new memory, okay? So this gets new memory, X new, and there 2 elements, and then we go and copy -1 and 3. Indeed, Y is unchanged, which is good. Y is unchanged. X is changed. What's the problem? What happened to this memory? We lost the handle, so we have a memory leak. But this is not the whole story. We have, to finish soon, some other things. So, I mentioned this is the name of the operator and constant reference because the things are to be kept unchanged. Why we return a reference to complex? Because we want multiple assignments. And this is when things become very unusual somehow. We haven't seen things like this. What we want is C is getting the value of D and then returns Z value D, which is allocated to be assigned something. We will stop here and we will continue after Monday. We will talk on Monday looking at this assignment operator in a little bit more detail. 12.